All right, so we took a look at a couple of examples of going from one interface to another interface, using the adapter pattern, using the class adapter, using the object adapter, and pretty much we saw that we could go one way or the other, and even having a two-way adapter that could make your objects generic, that you can use them anywhere, right? And anyone that was expecting either data type. Now, we saw that we could implement each interface in terms, each method in terms of the other. Right? There was a clear-cut way of implementing every single method in terms of some other method that was implemented by some other interface. Yes, and we didn't seem to have any issue there, but it's not always the case. It's not always the case, right? That the interfaces could be actually written in terms of each other. Even though they look very, very similar to one another, it looks like they're doing this almost the same exact thing. Okay, but nevertheless, there might be some edge cases that it's just the bridge cannot be the gap cannot be bridged. Sorry, English is not my first language. So here's an example of one particular interface that has since been deprecated from early on in the Java language, the enumeration interface, right? And the idea was that we want to be able to iterate over a collection of data. We don't know how big it is, right? It might be an infinite a set, right? It could be a stream that's being of data that's being generated by some detector on the field, right? That it's measuring the tides, or it's measuring temperature or whatever out in the field, and it's just generating a whole long stream of data. Yes, and we need to consume it. We need to consume it, and it says, well, give me the next value, give me the next value. So it could be a finite collection of data. It could be an infinite collection of data. Yes, so there's no set size or length to this collection of data. Yes, so the enumeration interface was created just for that particular use case, right? Of being able to just give me another one. Is there anything more? Yes. Well, give me it. Give me the next value. Give me the next value. Give me the next value. Yeah. And it provided this function these two declared these two methods. One of them is to query to say, are we done? Are there more elements? If there are, then I can ask for that next element. Yes? And it also generic, so it could be an enumeration of anything, of any data type. Okay? So anyway, so this particular interface eventually was deprecated. Was deprecated in terms of this more modern version of almost the same thing, right? Almost the same thing, the iterator interface, right? Notice that the methods almost have the same signature, at least the same theme of asking is there any other element? Is there any other data type instance? If there is, give it to me. Next. But notice that it has this additional single method called the remove method. Okay, this remove method is what's going to be the thorn, right? It's going to break this. Yes.
Isn't that mostly deprecated also? The remove method, at least that's the fire.
Yes, that is exactly what we're going to talk about. Yeah. So this is what's going to give us the trouble here, the remove method. Okay. Nevertheless, we might embark in this futile endeavor, that we might want to implement one in terms of the other. Perhaps we have a code that was written so long ago that it's still using the enumeration data type, yes, but we have iteration, and we might be tempted to use the adapter pattern and says, oh, well, I've learned about the adapter pattern, and I know I can write one in terms of the other. I'll just implement one, but inherit from the other, right? Or maybe I could use delegation or class. I could use one or the other. Yes. So let's go and try to do this. And perhaps I already have a client and the client is spewing out instances of this enumeration or this data type, and because I already have these data types, these objects are already instantiated. I go along with the object adapter. Right, I have these instances. Right, I'm going to use that as my delegate. Right, I'm going to pass it in my constructor, and I'm going to use it as a delegate so I can forward the methods to my delegate. Yes. So that even though it's an enumeration, I can treat it as if it were an iterator, right, as opposed to an enumerator. Yes. Okay. So we might get started and says, okay, well, what is it? Where's the mic? I don't. This? I'm sorry, I don't. Can you... Oh, that. Thank you. So here's my adapter that knows how to knows how to adapt an enumerator in terms of an iterator, right? That all my modern code that I already have expects iterator, right? But I have this old code that is giving me an enumerator. Yes, and so I can pass it. I can pass it in my constructor, this old enumerator, right, and copy it into my local source instance. And then I said, well, that's great. I can now pass around my enumerator iterator to anybody who's expecting an iterator. See that? Right? And I can still use this old code, this legacy code that I had the unfortunate luck to have to deal with all this legacy code. And I go in and start implementing it. Right? I start implementing. It says, okay, well, the iterator has 3 methods. I know it has the has next. I know it has next. And I know I can write those pretty easily in terms of the enumerator, right? And the has next is just equal. I'm just going to forward it to the has more elements, and the next I'm just going to forward it to the next element. Yes, right? Up until I get to remove. Up until when I get to remove, and I realize that the enumerator has no equivalent. Right? It has no equivalent of a remove, right? And so I start scratching my head. Says, well, what do I do with this remove? What could I possibly write in there? And so one of the things that I might do is say, well, I know I can what I might be tempted to do. Says, well, what if, right? I know the one that you're removing. I could just skip over that element, and I could just keep enumerating all the way to the end. Do a collection of this whole thing. I'll just return an iterator with that one element removed. Yes, yeah, that seems like a sensible thing to do. Right? I'll just collect everything that's left over with that one element missing. Right? I'll just continue enumerating. But that's actually not the point, right? I mean, that was the whole point of the iterator, right? The whole point of the iterator is that I don't know how big this is. Right, it could be an infinite set of numbers. Right, I could not. Maybe it's actually completely impractical to iterate to the infinity, right, and return something that does not have that particular element. Yes, right. There is no guarantee that the collection is finite. Okay, and the whole point was not to collect the elements into some big data structure and into a finite data structure. Is that I could consume these elements one at a time, as opposed to being able to collect them. Especially, for instance, consider a query in a database, right? And a database might have terabytes. Yes, might have millions of records. Right? It would be impractical to implement a query where you have to load every single record into memory before I start operating on them. Yes, it just make no sense. Instead, we have iterators, where iterators allow you to consume the rows in the database one at a time, right? And give you the illusion, right? Give you the use case of being able to go one row all the way to the millionth row, and then backwards, and you can jump around. Even though you're only ever touching a single row, yes. But it gives you the operations or the capability of visiting every single row without having to load everything into memory. Make sense? So same thing here. These elements might be a huge numbers of elements. It would be impractical to deal with all of them all at once. Yes? I still want to be able to consume them one at a time. Okay, so this idea of collecting the remaining elements is what breaks this, right? We can't do that. But we cannot guarantee that all these elements, there could be millions of records, right? It just makes no sense, right? So what we could do is just give up. It says, nope, we can't do it, and just says there is no equivalent to this remove method, and we're just going to throw an exception, right? If you try to call this, I'm going to complain, and says no, there's no way that this is possible, and actually it's okay. In some cases, it just makes sense, right? That there is no equivalent, right? There is no equivalent. And actually, the folks that implemented the iterator class, right? Actually, in their documentation, they understood that this might be the case, right? That not always makes sense for anybody who's trying to adapt this or reuse this. That remove will have an equivalent, right? In their documentation, they explain this, and that throwing this exception as an unsupported operation is a sensible thing to do, right? So it's in their documentation. So they document in there for that particular method that it's perfectly fine to throw an unsupported operation exception if you try to use this remove, right? Where there might be cases where things are infinite, where you're trying to remove an integer from the infinite set of integers just makes no sense, right? Yep. So it's fortunate that there are sensible cases where we just give up, right, and not implement certain things.